Unit 6, or Unit 1, Lesson 6, Scaling and Area, Part 1. So this is a two-part lesson. I broke it up because of the time. So I can describe how the area of a scaled copy is related to the area of the original figure and the scale factor that was used. I can find the missing length of a figure of two similar figures. Alright, so for our warm-up today, we're going to scale the pattern. So how many of each shape would be needed for this scale factor? So we're going to use the applet. So you're going to click the blue arrow. You're going to click back. Then you're going to click open. And then from there, I want to make sure that I have my work for today so that I can still write on it. All right, so it says using a scale factor of 2, using a scale factor of 3, and using a scale factor of 4. Okay, so I have one block here. If I wanted to use a scale factor, if I wanted to make it twice as big. Now remember, we're doing area, not the figure itself. So we're worried about the area. So that would make it twice as big, twice as wide, but I want it twice as big. So I need to consider the top two. So it says how many blue rhombuses would be needed to build a scale copy that is twice as big? Well, I know I'm going to have to go 2 over and 2 up. So that means I would need 4. So I'm going to use my drawing tool. Now if I wanted to make it 3 times as big, that means I would need 3 across the bottom, 3 across the middle, but then I would need it to be 3 high. So I would need 9. And then if I wanted to make it a 4, I would need 4 across the bottom and then 4 high. So I would have 16 blocks. Then if I want to do the triangle, I'm going to think about that one. So if I want it to be twice as big, let's see if that doesn't help. Twice as big. So that's twice as wide, but I want it twice as big. So I would need 4. If I want it 3 times as big, so I want it to go across the bottom 3, that'd be 1, 2, 3 triangles across the bottom, but then I need it to go up, so I need 3 across the side. So that's still only 2 up the side. So that makes 9 triangles. And I can count them to figure that out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now let's say I want to do a scale factor of 4. So that means I need it 4 across, and then I need it 4 triangles tall. So that would be, that gets me 4 across. Now I've got to work until I get a height of 4. So I have 4 triangles, 1, 2, 3, 4. So that would be 16 triangles that I would have. All right, then I'm going to do my trapezoid. So I have my trapezoid. If I want a scale factor of 2, that means it's going to be 2 across, but that's not even 2, that's 1.5, right? So now I have 2 because there's half here and half here, and then it's 2 high because I have one trapezoid on top of another. So again, that's 4 trapezoids. Then let's see, I want to go 3 across. So that's 1, that's 2.5. So now I have 3 across and 3 up through the middle. So that's 1, 2, 3 up the middle. So that's 9. So then if I want to make it 4 times as big, I would have the 1 and then it's 4 because they're sitting on their sides, and then it's 4 trapezoids up, so that's 16 trapezoids. So I want to stop here and think of exponents, because that's something we talked about last year in 6th grade math. And I want you to just think, and I'm going to switch colors really quick, but I want you to think about exponents. Remember that the base number, and then you multiply it by the number of times. So this one would be 2 squared. This one would be 3 squared. This one would be 4 squared. So that's one way to look at it. To kind of think about what's happening. So kind of keep that in mind. So now I'm going to click over to my next slide because I'm still using it. So then it says predict how many of each shape would you need. So if I have a scale factor of 5, how many rhombuses would I need? Well, if I go back to my exponent idea where I'm getting my exponents, I think it's going to be 5 squared. So I think I'm going to need 25. If I want a scale factor of 6, I think it's going to be 6 squared, or 36. So, and I think it's going to be the same all the way down. And predict just means to take an educated guess, or to tell me what you think is going to happen. Now let's go back to our applet and see if we're right. So this is where we stopped with 4. So if I wanted to make it 5 wide and 5 tall, I'm right, I would need 25 blocks. If I wanted to make it 6 wide and 6 tall, I would need 36 blocks. So let's see if it's the same with the triangle. So that was a base of 2 and a height of 2. So that's 4 blocks. A base of 3 and a height of 3, that's 9 blocks. So base of 4 and a height of 4, that's 16 blocks. That's 25 blocks. So it's working the same way. So if I was going to explain my reasoning, I used exponents. So I used exponents to think about what was going to happen. So every time, whatever the scale factor was, I had to square it. I had to use an exponent of 2 to figure out how many blocks I would need. So let's go back here. So practice problem 4. These two triangles are scaled copies of one another. The area of the smaller triangle is 9 square units. What is the area of the larger triangle? Okay, now I want to remind you that when we're talking about area, we have base times height divided by 2. So we don't know the base. We know the height is 3. We know we have to divide by 2, and we know our answer is 9. So I have to think, what am I going to multiply so that I can divide by 2? I need this right here to equal what so that I can divide it by 2 and get 9? I need it to equal 18. So what does the base of this triangle have to be? 6, because 6 times 3 is 18. 18 divided by 2 equals 9. So the base of my triangle is 6. So I'm going to use the same idea here. So it says find the area of the larger triangle. So let's think, if my scale factor here is 2, so I have a scale factor of 2, and I know I have a scale factor of 2 because 3 times 2 is 6, so now I've got to think of the same thing again. So 6 times 2 is going to give me 12. So if I want to find the area of the larger triangle, I'm going to do 6 times 12 divided by 2. So that means 6 times 12 is 72, divided by 2 is 36. So my area is going to be 36.